So we left off talking about the different temperature scales, Fahrenheit, Celsius, and Kelvin. And so there's the illustration of the three thermometers, and we're looking at the boiling point of water and the freezing point of water. The Fahrenheit degree is a different size than a Celsius degree. A Celsius degree and a Kelvin are the same size. It's just that we're measuring zero at a different place. The Celsius scale has zero at the freezing point of water. The Kelvin scale has zero at absolute zero, the lowest theoretically possible temperature. Well, we need to learn how to convert between the temperature scales. So if you're given a temperature in Celsius, you should be able to figure out what that would be in Fahrenheit or in Kelvin. And because of the relationship between the temperature scales, we cannot use dimensional analysis for this. We have to use an equation. So here are the two main equations that we use. The Kelvin, if we want to know Kelvin and we're given Celsius, we just add 273.15. If we know what the Fahrenheit temperature is and we're trying to get Celsius, we take Fahrenheit minus 32 to correct for the different in the zero place, and then we divide by 1.8. I will be giving you formulas on the exam. I'll give you a page of information. So you don't strictly have to memorize these, but you need to know how to use them and communicate with your calculator to get the correct answer. So let's do some examples. Let's convert 358 Kelvin to Celsius. So we need an equation to do this. The equation for Celsius and Kelvin is that the Kelvin scale equals the temperature in Celsius plus 273.15. So here we're given the Kelvin temperature and we need to find the Celsius. So we can rearrange this equation and say that the degree Celsius is going to equal Kelvin minus 273.15. So the temperature in Celsius is going to equal 358 minus 273.15. Forgot to get my calculator out. So the calculator is going to show us 84.85. Take the 5 into an 8. And the unit there would be degrees Celsius. Now what should we report in terms of significant figures? Are we adding, subtracting, or multiplying and dividing? We're subtracting. And so the rules for subtracting are different, and we should report two significant figures. This number has uncertainty in the ones place, and this has uncertainty in the hundredths place. And so then we need to report this to the ones place. So we're going to call this 85 degrees Celsius. Significant figures with temperature conversions can get a little messy, and so I'm going to tell you a shortcut. Look at your original temperature. The uncertainty is in the ones place. The number ends in the ones place. So after you do your temperature conversion, round your number off to the same place, the ones place. So this ended in the ones place. I'm going to end this one in the ones place. Any questions about that problem?
Will you give us instruction in the test, or will you just give us our number?
I'll give you the equations on a separate piece of paper with the periodic table. But you have to know how to use the equation. So I would give you these two equations. So convert 139 degrees Celsius to Fahrenheit. So we need an equation. The equation is degrees Celsius equals degrees Fahrenheit minus 32 divided by 1.8. That equation is great if we know the Fahrenheit temperature and we're trying to find Celsius. But in this problem, we have Celsius and we're trying to find Fahrenheit. We should rearrange the equation before we stick the numbers in instead of after. So this equation has a fraction in it. When we've got a fraction in there, people do crazy things. So my recommendation, unless you're an algebra whiz, is to get rid of the fraction first and then rearrange the equation. To get rid of the fraction, let's pretend there's a fraction on this side also. Do you remember something called cross multiplying? So cross multiplying is you're going to take the top of one side times the bottom of the other. So degrees Celsius times 1.8. And that equals the bottom here times the top there. See the little x there? That's cross multiplying. And so then we get 1 times the Fahrenheit temperature minus 32, which of course, multiplying by that 1 doesn't do anything, so let's get rid of that. So that's just that guy right there. We got rid of the fraction now, and so it's easier to isolate this degrees Fahrenheit. So we have degrees Fahrenheit minus 32. To get rid of the 32, we need to add 32. So I'm going to add 32 to this side, and that's going to give me just degrees Fahrenheit. And I'm going to add 32 to this side, and that's going to get me degrees Celsius times 1.8 plus 32. Okay, that's algebra. That's rearranging an equation.
Can we use that equation instead? Remember that one.
If you memorize it, absolutely. Absolutely. So degrees Fahrenheit equals 1.8 times degrees Celsius plus 32. So now we're going to put that number in, 1.8, and our temperature is 139. So 139 plus 32. 1.8 times 139 equals, and then we're going to add 32. And the calculator's going to give me 282.2. And the unit then would be degrees Fahrenheit. Now what about significant figures? The Celsius Fahrenheit conversions are even more tricky because you're mixing multiplying, dividing with adding, subtracting. And so here the shortcut really works out very nicely. Look at your original temperature. It ends in the ones place. So that means we're going to round this off to the ones place. So we're going to record this answer as 282 degrees Fahrenheit. Any questions? Let's convert negative 321 degrees Fahrenheit to kelvins. So the equations that we had were Kelvin equals Celsius plus 273.15, and degrees Celsius equals degrees Fahrenheit minus 32 divided by 1.8. What's the problem? We don't have one equation that's relating Kelvin and degrees Fahrenheit. Could you come up with an equation? Sure, you could. But it ends up being faster to just convert Fahrenheit to Celsius and then convert Celsius to Kelvin. So we're going to take this Fahrenheit temperature, and first we're going to find out the equivalent in degrees Celsius. So we're going to use this equation right here. So degrees Celsius equals, now we've got our Fahrenheit temperature, minus 321, and we're going to subtract 32 and divide by 1.8. When you do this on your calculator, you need to be careful to communicate the right thing to your calculator. So I'm doing 321 and I'm changing the sign to make it a negative number. I'm subtracting 32. And then I need to tell my calculator, finish that subtraction. So I'm going to press the equal sign to get the result here. I don't need to write it down, but I need to finish that and then divide by 1.8. When I do that, I get the temperature in Celsius is equal to minus 196.11 repeating. If I don't press the equal sign after the 32, 321 negative minus 32 divided by 1.8 equals, I end up with minus 338.77 repeating. The other thing you can do is put parentheses around that, and that will communicate to your calculator, finish the subtraction first and then do the division. Because your calculator understands orders of operations, parentheses, exponents, multiply, divide, add, subtract. Please excuse my dear Aunt Sally. So it's going to do the division before it does the subtraction. And you need to communicate to it, no, I really want you to do the subtraction first. So just be aware of that. You can have problems talking to your calculator. Okay, so now we've got the temperature in Celsius. So the Kelvin temperature will equal that temperature. I'm just going to put, well, no, I won't do that. That's minus 196.11 repeating plus 273.15. And so I end up with 77.038 repeating. And the unit there is capital K for Kelvin. Now, according to that little shortcut I gave you for sig figs with temperatures, how should we report this answer? 77, right, to the nearest 1 degree. And so we're going to say this is 77 Kelvin. Our initial temperature was measured to the nearest 1 degree. A Kelvin degree and a Celsius degree are exactly the same size, and they are only slightly different, less than a factor of 2 from a degree Fahrenheit. So if we're measuring to the nearest 1 degree Fahrenheit, that's equivalent to measuring to the nearest 1 Kelvin. And so that's why that shortcut works. And it saves us all the grief of trying to deal with all those sig figs. Any questions?